Okay, so for this problem is very similar to question 2. It's number 3. So y equals cos x, y equals sine x. These graphs oscillate among each other in waves, and it's something you should have memorized in your trigonometry class. However, if you didn't, you can just plug in values like 0, pi over 2, pi over 4, pi over 6, pi over 8 to get what it looks like. But I'm going to skip that part and just go ahead and draw it. So cos x starts at 1. So it's 0, 1, that's the first value. And sine x is the opposite. Okay? So sine x starts at 0 and then goes to 1. So sine x is going to look like this. And the values, they're not going to stray between -1, 0, and 1. And cos x is the opposite and starts above and oscillates like this. So they're basically just waves. And looking at this closer, if you have it memorized, you know that this is just pi over 4 and pi over 4, 0. These are our bounds. But if for some reason you didn't know, you could set these two equations equal to each other, use the unit circle, and find where sine x equals cos x. And then you have your answer. Because since it's bounded by pi over 4, the only ones that are equal to each other in that range will be pi over 4. So, in summary, our bounds is going to be this. Now I'm going to draw another diagram so we can look closer at our figure. So, it seems to be going like this. This is what it looks like close up. And this is y equals -2. The axis it's going to be rotated around. Do not reflect it around here because you will not have it rotated around the right place. There's a space here, which means that that same space is going to be here. So, it's going to look like that. And then drawing the figure, this is what the figure is going to look like. The axis of rotation, a good rule of thumb, it's always going to be in the middle of your diagram. So if the figure is not intersected in the middle by the axis of rotation, then you did not draw the diagram right. Now I'm going to use the washer method because we can keep the x values and it's a lot easier that way. In the washer method, we have an inner